Hello students, today we are now going to discuss about a question which was actually from previous year NEET. So this question is from electric charges and fields and based on the force that will be experienced by a charged particle in an external electric field. As we know, in this question what they are asking is an electron is falling freely through a vertical distance of h in a vertically upward directed field. The field is vertically upward, and this field is vertically directed upward, and there is an electron which is falling in the direction opposite to the electric field, vertically downwards. And now what they are doing is the direction of this field now is reversed. The direction of the field now is reversed, keeping the magnitude same. The same electric field, instead of vertically upward direction, we are taking now in the vertically downward direction. And in this case, instead of an electron, here we are having a proton which is allowed to fall from rest through a same distance of h. Now what they are asking you is the time of fall of electron in comparison to the time of the proton. Is it smaller? Is it 5 times greater? Or is it 10 times greater? Or is it equal? This is the question. Now for this question, the basic information that we should be knowing is that when you have an electric field, for example, I am taking an electric field in the positive x-axis direction here as you see on the screen. Now in this case of the electric field of intensity E bar, if I take a positive charge, assume I am considering a positive charge which is of magnitude q, positive charge of magnitude q. So this is placed in an external electric field. In this case what happens, what will be the force that will be experienced by this positive charge, and what will be the direction of that force? See, in general, the direction of the force that is experienced by a positive charge will always be along the direction of the field, and this will always be equal to q into E bar, or in this case if I consider the force experienced by this positive charge will always be equal to F bar, which is equal to q into E bar. The direction will be along the direction of the field. Similarly, if I take a negative charge which is placed in the same electric field and assume that this negative charge is also having the same magnitude. So in this case what happens is the force that is experienced by the negatively charged particle in an external electric field is always in the direction opposite to the applied electric field, and its magnitude will be F bar is equal to q into E bar, and you can write it as minus q into E bar, and this negative sign here indicates that it is in the direction opposite to the applied electric field. Using this concept we will solve this question. So now here they have given two charges, one is an electron, other one is proton. Generally we clearly know that what is the force experienced by a charged particle in a field? Force experienced by a charged particle is, we know that F is equal to Q into E. This is the force experienced by charged particle which is actually put in a external electric field of intensity of magnitude capital E. And also we know that force is equal to mass into acceleration, which is according to Newton's second law, where mass being the constant quantity, we take the derivation of F is equal to ma. Now from the above equations what we can write is, mass into acceleration is equal to Q into E. Mass into acceleration is equal to Q into E, which is charge into E. So here acceleration of the charged particle will be Q into E divided by mass. Q into E divided by mass. So now using this relation we will calculate the time. How do we calculate the time? For example, initially in the question they gave, if I am taking the field vertically upward in this direction, this is the direction of the field, vertically upward direction, What is actually happening? Electron is falling vertically downward. This is the direction of the electric field. Sorry, electron falling. And what will be the force? F is equal to Q into E bar. As we already discussed in here, the force experienced by the charged particle will be vertically downward. This is the one force which will be pulling it downward. Okay, and other case is if you have electric field downward and you have a proton which is positive charge proton falling downwards. Why will it be again downwards? Because you can consider that it will be opposite, but thing is here the proton means here if the electric field is vertically downward, the proton is also going to be falling vertically downward, because the proton will experience a force which is F is equal to Q into E in the direction of the field. So because as their charges are same, electron have the same charge and proton also have the same charge, the force experienced by the electron and proton in this constant electric field which is reversed also will be the same, but the directions will be different. On the force directions on the electron will be opposite to the field, and force direction on the proton will be along the direction of the field. That will be the only difference here. And concluding to this relation, what we can further go is with as the both electron and proton are falling from rest, we can take their initial velocity to be equal to 0. So initial velocity u is equal to 0 for both proton and the electron. The velocity is 0. So using S is equal to ut plus half at square, and here if you observe initial velocity is 0, so this whole term becomes 0, and S is equal to h, so what I can write is h is equal to half into at square. So acceleration is what? According to us, we got the value of acceleration as QE by m. This is the acceleration of the particle. So if I replace it with a with the acceleration which is 1 by 2 into q into e divided by m into t square is what I'll get. So using this relation, I can calculate the t value as t is equal to 2m into h divided by q into e under the root. So if you observe now, as I already told you very clearly, what did I tell you? I told you that this h is constant in the question given, e is also constant is given in the question. Here charge is also constant because charge of proton and electron are the same, and 2 is a constant and only it is depending on the mass. So what we can write is time taken will always be proportional to root of the mass in this question. Now using this relation, what we can conclude is that as the mass or as the mass of electron is smaller, it will take smaller time. So hence we got the solution here. Means what is the comparison here? So what is the time of fall of electron in comparison to the time of the proton? As the mass of proton is greater than the mass of electron, we can easily say that the time taken as time is proportional to the root of mass, we can directly say that it is smaller. Hence we can consider that the time taken by the electron is smaller compared to the proton. So this will first option will become the correct option here. Understood? Hope you understood. Thank you.